All right, ladies and gentlemen, welcome to this video. We're doing things differently in this video. I've decided, since I've been watching a lot of other creators like Kine Returns Machining, boy, is that guy a great engineer, and, Black Steel Studio. I decided, I can muster up about, 5 to 7.5% of their personalities. So I'm going to give this voiceover thing a little try. We're going to do a lot of fun stuff in this video, including designing some custom designs just to actually allow this test to work better. So stay tuned and we will go through that in meantime. I should probably clarify a few things. Even though I've shown printed materials on this channel, I've actually been somewhat cosplaying as the owner of this 3D printer. It's actually never really been in my building. It was always at work. But now, I'm glad the old office let me have it. So now we're going to be doing fun stuff with it in the office. So what I've done here is just brought all of the different parts of the table down. The table itself is not very interesting other than the fact that it's a sit stand table, but it's not electric, it's hydraulic. Not much else that's interesting about it really, other than the fact that the guy that I bought it from on Facebook Marketplace was, grumpy AF in the middle of the transaction, because I was talking to him as a fellow engineer trying to actually, figure out a few things. And he looked at me dead in the eye. He was like, dude, can we please get on with this? This is a work day for me, even though it was Good Friday, but I guess it was some sort of contractor, but it was awkward there for a minute, but we got it done. So as I mentioned, there isn't really much interesting about this table, and there's no reason for me to allow you to suffer you watching me build it. So while this is being built, I'm going to take the opportunity to actually introduce myself on this channel, because I realized I posted 5 videos on this channel now, and you guys don't really know who I am, right? So I'm going to try and, put a bit of color on that. So my name is Akin. I'm a family man. I live in Hertfordshire, just north of Stevenage. I have a wife and a child. I will classify myself as a very lazy runner. And one fun fact about me, actually a couple of fun facts about me. I do not know how to ride a bicycle. And I recently learned how to swim as an adult. So now I'm also a very lazy swimmer. So there you go. In terms of background, I've always really been a mechanical engineer. So I started my career with a company in Swindon, designing combustion fans and combustion blowers. After about 3 years there, I decided to move to Dyson to work on a lot of their fans and a lot of their drive systems and motor drive systems. I'm not one of those guys you see on LinkedIn that put ex-Dyson in their bio. I don't consider working at Dyson as a as a badge of honor, especially considering the direction the company is taking right now. But I guess some people are still, drunk on the Kool-Aid. Good luck with them. So I was made redundant at Dyson in 2020. So yeah, you can spot the trend now. 5 years later, I'm basically the same place. So yeah, after that redundancy, I decided I want to actually, use a lot of my engineering time to actually work on things I find a bit more meaningful, find a bit more with the things with a bit more substance. So I decided to pivot and actually start working on medical devices. I was lucky enough to get a job at a medical device startup, designing class 3 active implantable medical devices. It's funny enough that whenever I tell people that, shout out to my guy Salami Builds, he always kind of sarcastically looks at me like, can you make your title any longer? So yes, I can. My official title is, or should I say was a principal mechanical and product engineer designing class 3 active medical devices. It's always interesting the responses and the reactions I get when I actually tell people about the details of what I do. Some guys, listen and find it, interesting and rewarding and worthwhile. While another group of people just kind of look at me like, oh my God, this guy is a psychopath. How can you do this? One of those being my lovely, beautiful wife, by the way. Don't worry, she doesn't really watch this video, so I feel like I can talk my ish on this channel. I'm sorry, baby, don't leave me. I love you very much. But jokes aside, I absolutely love working on active implantables. It's taken me all over the world and put me in rooms and positions that I've never really imagined. So I definitely love to try and remain within the industry. But right now, we're giving this YouTube thing a little try. So please, like and subscribe, help a brother out. As I mentioned at the beginning, I actually really, really need it now. In terms of, the target who I'm trying to talk to with these videos, really, this channel, the content we're making is actually really it's targeted towards the, DIYers, and aspiring professionals, people that actually really want to learn to use the tools like Onshape to actually design their own stuff and look within the environment and actually, create solutions to a lot of the problems that they see through designing. So that's what this is for. I don't really talk so much to the artisanal Pokemon printers on this channel, but we love you guys too. But yeah, we are here to help people that want to actually learn to use the tool. So what you're looking at me doing right now is actually trying to figure out why the 3D printer is not switching on. There are actually 4 switches that needed to be on for this to actually happen. There's a switch at the back of the printer. There's a master switch on the power supply. And then there's a socket switch. And then there's a switch also in the socket on the ceiling. So yeah, all 4 of those need to be on. So at some point, I'm going to use my engineering brain and actually figure out that one of those isn't on. And then right now, you're going to see the printer come on. So, that was interesting for a little while. So now we're just about done with the setup now. You can kind of see the scope of what I've been able to score. So I've got, Bambu Labs X1 carbon. And then there's also a Weller soldering station there. There's a multimeter and some other bits and bobs. So this will allow me to actually, mess about in the basement a little bit and try and create, some interesting projects coming soon. So right now, before we can actually start printing anything, we're going to actually jump into Onshape and design a chute for this 3D printer to collect the excess filament. So it's all set up. So got a soldering station there, some solder, some jumper cables, a soldering mat, the mat and the table mat I bought on Amazon, the power supply. Initially, it was there, but it was a bit of a mess, so I've just moved a few things around. And then the 3D printer. So what I'm going to do now is I'm going to set this up on the home network now, but before this can run, I need to design a few things for it. I need to design a chute for the poop, for the excess filament that comes out of the back. So I need to design that, and I also want to design a bracket for this so it doesn't kind of flop up and down anytime I try to plug into it. So let's jump into Onshape now and do designs for this. In the meantime, I'm going to set this up so that I can run on the home network and fire up some test prints in the meantime while we're designing in Onshape. So what you're watching me do here is to create one of the 2 CAD designs that we actually needed to create for this new table setup. So this is for the chute at the back of the printer that collects the excess filament. So this is I would say, probably the least interesting of the 2. The CAD for the table, for the bracket, for the power supply was actually a lot more interesting, as I brought in a lot of the concepts and applied a lot of the concept that I've actually talked about in my previous videos in that. So stay tuned. That's coming along. But rather than watch, let me let you watch me vibe CAD these as I was making a lot of as I went along here. I'm going to release a standalone video on this, as well as a standalone video on the power supply bracket for this oncoming on the channel. But in terms of the design itself, so what you're seeing here is just the 3 holes for the magnet that allows it to magnetically connect to the back of the printer. The design itself is in 2 pieces, so there's a chute part where the excess filament slides on. There's like a collector basket at the bottom of it, and there's a dowel pin in the middle of it, right in the middle of the collector basket, that actually aligns that properly. One thing I'll say here is that perhaps the circular magnetic hole is not the best. You probably want something that's hexagonal because of just how this prints as like a seam that makes the magnet always kind of difficult to go in. But at this point, I thought I was done, except I wasn't. So lo and behold, I'm going to put this into the bamboo slicer and then realize it's too big. I couldn't actually fit it onto the plate, which is actually one of the things I've actually begun to notice about this printer is that it's actually quite small compared to the the H2D out there, right? Which is a kind of newer model that Bambu Lab sells. So what I'm going to do now is actually just jump back into the card and try and split this into two, and then print that as a two-piecer. So what I'm doing now is actually just adding a plane to where I actually want this to split. I actually kind of like this feature with Onshape now where you can actually select what you want, and the system actually guesses what you're trying to do, because I could never figure out which options to actually select when I'm selecting planes. So now that that's done, I'm going to use the split phase feature right here, using the plane as a split point to actually split that part into two. So the next thing I'm going to do now is actually now put a sketch on that face. I'm just using I'm creating a slot here, like a dowel slot, which allows me, so there will be a male on one side and a female on the other side, right, which allows me to actually join this together temporarily until I'm able to actually glue it. So it serves as the attachment point. So that's kind of what I'm doing here. So I'm creating that geometry now, and then labeling, as you always remember, constraining and dimensioning, as I always say on this channel. I'm watching you. Constrain your sketches. I don't want to see no blue dots, no blue ticks, nothing on your sketches, unless they are like letters, alphabets, other things. In that case, it is acceptable for you to not, constrain your sketches. So right now, I'm going to make this line, construction line. I'll do that a bit later. I'm putting in dimension of the slot here, right? So it's just a very small slot. As I mentioned, it's just a joining point for this. So next up, so now that line is going to be a construction line. Then I'm going to exit that sketch and then extrude remove this right from that surface inwards. One thing about the way the plane was created is that it's actually created kind of parallel to the part. So I'm checking here that the plane is actually parallel, so it's kind of not going at a different angle to what was already there, right? And that's just because of where the plane was created. It was kind of created, perpendicular or normal to where, to the face that I want it to be. So whatever I'm creating will always go in direction of that face. So right now I'm just adding a chamfer. I would go back later in the model and actually redo this, by the way, but that's where we are at the moment. So now I'm creating another plane for the midpoint between the two edges, and then I'm just going to mirror that feature that I've just created. So I'm going to select the feature mirror here, select the chamfer and the extrude, and select the plane, and then that then mirrors that to the other side. So now I've created the male part of the joining feature. So what I'm going to do now is I'm going to hide that part, and because the plane is the split point between the two parts of the shoot, that plane is automatically reflected on the other part of it. So now what I'm going to do here is then create the female part using the same plane and the same sketch. So I'm just going to extrude remove this to create the female part, and it just needs to go in, just deep enough, right, for this to be usable, because as you can see, there's kind of like a curve going around there, right? So I don't really have that much space to actually get this to go much inwards, but there was just enough space in there for me to actually, create the pocket for this. And I'm going to do the same thing here, add a chamfer, and then I will also then mirror this to the other side using the planes I've already created. And that's kind of the beauty of this, isn't it? That I don't actually have to redo this, because all of the planes were created in place and where I want them to, so it can actually just be used on both parts of the shoot. So now that that's done, I think at some point I actually then decided that, because right now it's size for size, isn't it? So one of those holes need to be bigger than the other. Either the male is smaller than the female joining portion, or the female is, it's bigger. You get what I mean? So I'm actually going to go back now, and actually I have to think about the best way to do this again, figure out how to actually either make this smaller or make the hole on the female side bigger, or the corresponding slot on the female side bigger. So I think what I did here is, I think I initially wanted to take the lazy part and actually kind of use the move face feature, which, you know, I actually don't like. I actually remember when I started at Dyson, right, they used to tell us that never use synchronous features. That's because that's what these are called, right? Synchronous features, to actually, you know, change features, right? You want to actually go by sketches. So, you know, I changed my mind there and I decided I'm just going to just edit the sketch. So what I'm going to do is go back and actually offset my original sketch. I think I chose about 0.2 here, right? Offset that by 0.2 and then use the new sketch, the bigger offset sketch, to create the extrude remove on the female part. So that's what I'm going to do here. So what I'm going to do, I'm going to roll that back. So I didn't do any more changes to this extrude here other than just re-add the chamfers, I think. Well, roll that back, roll that all the way back to the bottom, and then I'm just going to hide it now and then move on to the other part, right? And then update that extrude to use the initial sketch and also the offset sketch, right, to make that all bigger. As you can see here, the chamfer disappeared because the reference was missing, so I re-added that. And because that's a mirror, right, it should automatically transfer to the other side of the shoot without me having to do anything. And that's exactly what happened. And just like that, this part is just about done. I didn't do any more changes on this, and it's ready to be sent for printing as a 3-part design, 2 for the chute and 1 for the collector basket. I did some tweaks on the connector bracket just to make it a bit smaller because I realized I didn't actually need it to be that big. But other than that, this was pretty much done. And look out for the standalone video of this to actually go into more of a deep dive on this design. So this is the print of the collector basket finishing right now, and you can kind of see the dowel pins that I mentioned earlier. So the 2 dowel pins at the bottom of the slanted part there, which connect to the 2 holes on the chute part itself that's already printed here. You can see a bit of excess filament actually kind of sliding down on there. The dowel pins are not strictly necessary because the collector basket were lying on the side anyways, but you know, I think that needed like a bit of a foot to actually get it to sit on the mat. And you know, I just thought, you know, I'll add that as part of the design. It really didn't, you know, hurt or, you know, improve it in any way. But overall, you know, drama-free print, and this is me just testing it out and what I want to hear, really. Nice fit. And just like that, the print is done. So now we're going to move on to the design for the bracket for the power supply, which was actually a lot more interesting, as I mentioned. Perfect. So what I'm doing right now is just setting up the initial sketches for the bracket part of the power supply. So I took some measurements of the profile of the benchtop power supply, and you know, and what I'm doing here is just the beveled edge of the table. But as I mentioned, a lot happened there, right? There was a lot of testing and a lot of things I had to figure out. So I'll also be releasing a standalone video of this, actually detailing and giving a deep dive of a lot of the concepts that I actually, you know, did it to actually ensure that we had a good design. But for now, here's the final design for the benchtop power supply, and look out for the follow-up video on this. So this is the final design of the benchtop power supply bracket. This is actually the more interesting card challenge compared to the other one, as I actually had to introduce a lot of concepts that I've actually covered in my previous video. As you can see, this is in 2 parts. So there's the main bracket that follows kind of the edge of the table, the beveled edge of the table that's going to go onto, and there's also a screw part down here that's actually a remix or a reuse of a previous model that I've actually covered on this channel here. So I will actually show you. I actually brought that model into this part studio and actually used it to actually inform the design and actually create features with it within this design here. The eagle that among you might have also noticed there's like a shoulder here, so that implies there's a right and a left side of it, and you'll be correct. So using configurations within Onshape, also I was actually also able to set up a right and a left side of this all within the same model. So I'll also cover that in the standalone video. As you can see, it's actually kind of updated there, and I'll do that again. So keep an eye out for that video and the video of the shoot. But for now, I need to send this to the printer. So let's get this printed and installed and finish the installation of the prototyping desk. So after, a couple of touchy moments in here, because at some point my prints decided to not adhere to the bed plate, I finally was able to actually get the brackets print. At some point I had to actually remove the printing plate and actually give it a sew path, and got lost a little bit in the weeds of print settings and plate settings. But overall, it came out okay, and behold, the final review of the desk. So I've kind of left a teaser here of the kind of projects I'll be working on. Funny enough, these videos so far don't have a large audience, but one of the few comments I had from Israel Mendes, shout out to you, Israel. He asked me about, working with e-ink displays. So, this is for you, Israel. We're going to be getting a lot of e-ink content on this channel coming soon. But as you can see here, you can see the bracket at the edge of the power supply in there, holding it nice and snug, and you can see the screw underneath. There are probably better designs out there. It's probably not the very best, but in medical devices, we have a saying that says if it's good enough, it's good enough. So, we're just going to roll with it for now. I might need to do some work on, cable management underneath the desk, so to make it less of a mess, but that's not for today's video. But overall, the setup is done, it's completed. Looking at this table though, I wish it was kind of longer. I was hoping I'll get some more shelving on the desk. Kind of to the right of the soldering station as you see there, but that's an issue for future hacking to look at. Perhaps I'll just change the tabletop and keep the base, but stay tuned. If anything changes, I'll let you guys know. A couple of things I still do need is a couple of things I still do need is an extractor before I can actually start soldering on this table here. I'm actually crazy enough to think I might want to actually design one myself. I'm kind of thinking maybe like a concept that can kind of magnetically attach to that metal base, but it's in my head. One thing I do want to design though that I'm actually actively working on right now is a storage solution for my filaments, kind of like an AMS light, but without all of the the fanciness of the AMS. Perhaps something that can give me humidity state of the filaments in the box, and also the status, how much is actually left on each filament. So I have ideas about using ESP32s and e-ink display to actually achieve that. So keep an eye out for that on this channel. But for now, thank you guys for joining me. Don't forget to like and subscribe to the channel. Catch you on the next one.